Growing a better world together. Rabobank.
Welcome to the last day of J-Spring, or as somebody mentioned in the Discord channel, Tropical J-Spring. A little bit of advice: keep your refreshments ready when you listen to our speakers. I'm Hans Klabbers. I work for Rabobank as IT architect in one of the payment teams. And I will be the host for the first session of today. You're all invited to join our chat. We have a widget running on our website, but if you want to use the full capabilities, such as direct messaging, join Discord in a browser tab or the app by clicking on the button above the chat. In the widget and in the browser tab, you can join as a guest or make an account easily. We have multiple channels set up, so you can talk to the speakers or the sponsors, browse through the chat rooms, and we will see you there. Don't forget to follow NLJug on Twitter, join our LinkedIn group, or subscribe to our YouTube channel. You will find interesting presentations and J-Spring content will be posted there in a few weeks. I would like to take the opportunity to thank the sponsors. The sponsors make J-Spring possible. So big thanks goes out to Rabobank, the Rijksoverheid, and Topicus. If you have any questions for them or want to chat with them, you can go to the Talk To channels in Discord. And now it's time to welcome today's first speaker, Wouter Oet. He will talk about agility in a regulated environment. Wouter, please go ahead.
Thank you, Hans. Hi, good afternoon. Welcome all. Welcome to the talk Agility within a Regulated Environment. This is a bit different for me. I'm used to standing in front of large groups of people or smaller groups of people, but now I'm looking at 3 cameras and I'm not quite sure where to look, but we'll figure it out as we go. I'm really pleased that you joined in for this. I'm going to start the talk off with a couple of juicy definitions. Starting off with what do I mean with agility? Well, it's kind of similar to Scrum, but I mean it more in a general sense. How can you be flexible? How can you respond to changes in your organization? How can you go fast, even though you're regulated and there are some stricter rules that you need to adhere? Well, and then the second bit is, of course, on what is being regulated all about. That one. Let's talk about regulation. Well, what is regulation? Well, regulation isn't that special. We are all, in the sense, being regulated. It's commonly known as the law, and they're there for a good reason. We all agree that stealing is bad, so we shouldn't do it, and so we made that into a law. But regulation is something more than that. It's a higher standard of doing stuff with stricter requirements. And those regulations apply to some companies, but not all companies. And then the question arises, okay, why do these regulations apply to some companies? And for instance, those apply to, of course, banks, but to insurance companies or power utility companies. So why do they apply to them, but not to other businesses? And that's really easy to explain if we take into account a local store, for instance. You have this store in Utrecht, for instance, where I live and where the Rabobank is. Although nowadays with Corona, that doesn't really matter anymore. But let's say that store closes down because the owner gets sick. Well, the amount of people who will be affected is quite little. There are not a lot of people affected by it. And even if they find themselves in front of a closed shop, they can probably move a street or two over where they can find a similar shop where they can search for phones, for instance. And even if they are affected by this, the effect on their lives is not that great. They have to walk 2 blocks more, but that's about it. That's different when it applies to banks or to power utility companies. Because if financial services are down, a lot of people are affected. If power is down, a lot of people are affected. And they're also affected in a grave way, because let's say your financial services are down and you're in the supermarket with dinner for tonight and you can't pay. Well, that's a severe impact on your life. And if the power is out, you probably won't be able to browse on the internet, watch Netflix, and especially now we're confined to our homes, that should be quite annoying. So there are companies with, if something goes wrong, it has a high impact on our lives. And the rules and regulations are there in place to prevent this stuff from happening, or at least happen less often. They're there to maintain our way of living. Now, I do realize that for all of you watching that you're probably not all working in a regulated environment, and that is fine. And I'm convinced that this talk is still applicable to you, because we're going to talk about some tips and tricks, and you can also apply those in a non-regulated environment to get the speed boost we all desire. Now, why do I know a little about this stuff? Well, my name is Wouter Oet, as mentioned in the intro, and I'm a software engineer at Rabo. The team that I'm working for is responsible for an application which basically takes internet traffic and routes them to backend applications. And if that application goes down, this has a great impact on the app and on the website, and thus has an impact on the lives of people. So it's a quite important application, and in this context, I learned a thing or two. Now, these regulations, they have an impact on the entire way of working. They define how you can do business, who you can do business with, how you need to develop, how you need to do operations, how you need to do security, etc., etc. They impact the entire way of working. But that's a too broad subject for today, so we're only going to focus on the development side, my favorite side. And since it is an online development conference, that seemed most applicable. We're going to start off with the CIA principle. And I don't mean the Central Intelligence Agency. The CIA principle is a framework of reasoning about the security of applications. And it's an acronym, and it consists of the 3 parts. Confidentiality is the first one. And it basically defines how privacy sensitive is your information. Is the information your application handles. What happens if someone gets access to that information which shouldn't be able to access it? What would be the impact on the lives of the real data owners? The second one is integrity, and that's also about data. It's about how trustworthy is your data, how consistent is your data, how pristine is your data. Accuracy also describes it really well. And the third one is availability, and that's of course the most easiest one. The easiest one is the service that I'm providing still available, even in case of significant higher load. Is there higher load, or when there is a failure in the system? To get this framework in mind, we have to do a couple of things. And the first is to define the levels, because these 3 parts get a rating. And this rating is usually on a scale from 1 to 3 or 1 to 4, depending on the organization you work in. with 1 being the lowest and 3 being the highest, and the higher the rating, the higher the requirements. So let's say you have an application with a 333 rating, that have a really, really important application with high consistency, high availability, etc. And the ones are of course lower, because not all applications that we use are being regulated. The script that I use to check the status of a pull request is probably not regulated, but the application handling all the internet traffic from the app to the backend is regulated. So we need to define those levels, and we need to do 2 things for that. The first thing is properties. So let's say we have this application, and it handles financial data. Well, then we immediately know that the C rating is really high, because the only person that should be able to access your financial data is the owner of the financial data, and no, I wouldn't say no one else, but it's very limited, and this is a characteristic. Is always limiting the amount of access to it. We could also say that for your account information, I want a high integrity, because if your account, the amount of money you have in your bank account would change randomly, that would be quite annoying. And availability should also be high for those kinds of applications. And once we have known these properties, then we define a certain level they are associated with, and then we need to define some measures. So what kind of measures do I want to have in place when we have a rating of 1 for C, or a rating for 2 for C, or a rating for 3, etc. And examples of that for C is, for instance, I totally forgot. Now, for integrity, we could, for instance, instead of writing a value directly to the database, we're going to write a change log, and then calculate the value by applying the change log over and over again, so that when there is a change, it's clearly shown and it logs an audit trail. And for availability, for instance, we could say, okay, you have an availability of 1, well, then you at least need to deploy into availability regions. And higher, then you scale up a certain amount of instances so that you could handle certain traffic spikes and failures of an entire region. Now, the next step. Next step is grading applications. So now we know what kind of properties we have, what kind of measures we want to take. Now we're going to look at the applications we have, or the applications we want to write, and we're going to define those ratings for it. And then we get results. And what do I mean with results? In this case, it's really easy now to reason about applications. I'm going to introduce a new application that handles this kind of traffic, this kind of data, that then we immediately know, okay, this has a C rating, so this application needs to have these measures implemented. And then you can take that into account when developing or designing your new application. And then the benefit is that it really stops discussions. You can easily say, okay, we've defined that if you handle financial data, then you automatically get a C rating of 3, and these measures are associated with it, so we need to implement those, or equivalents, of course. Another benefit is the platform which you run on, and we'll get to that now. So you'll all have a platform where you're running your application on, whether that's bare metal or a Docker container, or you're running it in a Kubernetes cluster. But what I mean with the platform is a platform which already provides some of these measures, so that when you're deploying an application, for instance, for availability, that already supplies auto-scaling, failover, and for that kind of stuff. But I want more out of the platforms I use, because we as a team, we build primarily Spring Boot applications, and I can imagine that some of you are also building Spring Boot applications. And these applications, they usually have something in common. And there's some kind of stuff that I just don't want to do, and especially don't want to do the X times that I have applications. For instance, runtime updates. If there is a new Java version with a new security patch, I don't want to upgrade all my Docker containers. I don't want to handle that. I want the platform to provide that for me so that I don't have to worry about this. The same with, for instance, logging. All my applications produce logging. I don't want to be responsible for configuring some adapter which sends it, for instance, to an Elk stack or Splunk or something equivalent. I want the platform, for instance, to just look at sysout and sysr and just write that to the stack. Same with externalizing information. I don't want to repeat that. I don't want to offer my applications for security scanning every once in a while. No, let the platform handle that. The platform should be aware which applications are running. It should be able to access those, and then you can start security scanning. You don't have to bother my team. Another one is certificate rotation. And basically the idea behind this is these are all steps you need to do to be compliant, and auditors are look for these things. But they can be solved either in every single application, and granted, it won't be a lot of work in every application. It will probably be copying of the log4j or whatever you use configuration file, but it's still work, and it's still sensitive for making errors because you can forget. And it's annoying when there is an update and you need to go through 12 or how many applications you have to do your change. Now, what does that provide more? It comes at a cost. It's a great initial investment, but this pays off every time you create a new application. There's one place to implement, like I mentioned, and auditors are also happy because there's only one place to check. Okay, let's continue.
Wouter, can I ask a question?
Yes.
You talked about updating the runtimes, for instance, on the platform. Aren't you afraid that when updating the runtimes won't break anything, or updating the logging mechanism or the certification rotation, all these things can break also something?
Yeah, good question. Of course, with every change, there is an associated risk that something might break. But I think the environments we're working in, we're used to building against a contract. For instance, I'm calling a service, and as long as they adhere to the contract that we negotiated, then the interoperability is fine. And I think that same level applies to runtimes, for instance, because if I use Java, and I don't mean then the runtime should upgrade from Java 7 to Java 11 or a step in between, but small increments within that range, those are fine because we make the agreement that I run Java and I don't use reflection to touch stuff that I'm not supposed to touch, then it's fairly limited the amount of risk that is involved. But there is a risk, and I think that a platform, you should be able to recognize that a failure happens and then roll back a change, for instance, so that even in the unlikely event that something is going wrong, that you can revert to another scenario.
Thank you.
Cool. Other questions?
No.
Okay, then we'll continue. Next one is config as code, and for those not familiar with the concept, is basically treating your configuration, which you of course have externalized from your application, and treating it as an artifact, and then in a sense of an artifact which is released and versioned. And if you, for instance, put this in Git, then you automatically get an audit trail. You know exactly who changed what, and if you write proper Git message, Git messages, commit messages, then you also know why something changed. But that's of course up to you. There is some overlap with infrastructure as code, with tools like Chef, Puppet, SaltStack, that kind of stuff. But we won't go into that. I want to talk about two examples that we use at Rabobank, especially in my team. So we have this application which allows traffic from the internet to route to backend applications. Well, of course, we don't allow just any traffic in. It has to be on a registered endpoint. And that registered endpoint, that is configuration. That's something that we have. And that is in a Git repository. And our workflow has changed in the few years. So we have this Git repository where the endpoints are defined. And now other teams, so not my team, but other teams can make changes in that repository. They fork it or branch from it. They make a pull request, and then we review it. And when it's merged, the configuration is automatically reloaded, and the traffic can flow. But the benefit here is the arrow part. It's the process of a pull request in this case, because we recently wrote a bot. So the first benefit is that when it's in Git, people don't have to visit you or contact your team, because they can just look at the repository, read the README, and try to make a change. And then when they make a pull request, then we have this bot which verifies that what they did applies to some rules. So this is config as code. But a better example, I think, is our newsletter. And that's a really simple example, but that's basically showing how far you can take this principle. So we write services for other teams to use, and once in a while we send out an email to inform the teams, hey, this is now what we have built, you can use this, or this has changed, or whatever. And the email that we're going to send out, that is will be first put into a Git repository, and there is a build process which will send out a test mail to registered test users, and when it gets merged to master, then the actual mail is sent, so we don't touch any mail clients directly. But one thing that we did is, let's say you want to add yourself to this mailing list. Well, we have this Confluence page, and you can add yourself. You want to remove yourself, you go to the Confluence page and you remove yourself. Because config as code doesn't necessarily mean that it's in Git. It means that it's in a version system, and Confluence, although limited, is versioned. So it allows you to be more flexible with processes, and allows you to automate processes further with additional checks, with additional bots, and in that sense make it easier to make changes and in a compliant fashion. The next thing I want to talk about is a singular pipeline. I'm sure you're all using CI/CD tools like Jenkins or Azure DevOps or GitLab or something in the lines. And when you build your first, let's say, Spring Boot application, we'll use Jenkins in our example. You define your Jenkins file, you'll build your pipeline, and it runs for a month or so when your PO asks you to build another microservice. And this microservice also, of course, needs a pipeline. So what do? Well, you copy the Jenkins file, paste it in the second one, modify it a bit, and as time progresses, you'll probably end up with numerous pipelines. And this is a risk, because what will happen is you'll make an application which is not only a Spring Boot application, but also has this small front end which you've included in the same Git repository as convenience, and you make a slight adjustment to the build pipeline to allow the front end to be deployed. So now in regulated environment, this is really problematic because now you have two pipelines, or now you have multiple pipelines, but you've at least two versions of the pipeline which make changes in a production environment. So what you then need to do is you have to verify that these two pipelines are compliant in a sense. And a form of compliance is, for instance, using the 4I principle. So a single person shouldn't be able to make any change and deploy it to production. There should always be at least two persons involved. And this is a risk. So what we did is we wrote a pipeline library for Jenkins, and we're now writing a pipeline library for Azure DevOps, in which not only we as a team, but we as our entire area can deploy applications. And we baseline on Spring Boot and front end, and we allow different kinds of variations. For instance, you can deploy stubs when you run it to a test environment, but we have this singular pipeline definition which is invoked via multiple parameters which you can tweak. And this is a real benefit because now there's only one pipeline, there's only one pipeline definition, and it's easier to verify that that's working correctly. And now, what should be in a pipeline to be compliant? Well, you need to focus, for instance, on code quality. So tools like SonarQube, which we previously discussed, like Fortify or checkmarks, there are those kinds of tooling. You have component lifecycle management, so that you're not using older components with known vulnerabilities in it, and that you can upgrade. Secure code practices, monitoring and alerting, you put that in your pipeline. So if you put this in your pipeline, that every time you introduce a new application, you don't have to tweak your application to support it. It will be done by your pipeline. And with monitoring, of course, comes alerting, so that you get notified when there are some issue with your production environment. And very important in regulated environment, it's change management. It's registering that something has changed, usually also associated with a risk analysis. So what's the risk that if I deploy this feature, what could be the impact on the end user? And that needs to be included in your pipeline as well. Now we're going to look at some things that we want to do in the future to more enhance how we build code and remain compliant, but still do it in a turbocharged way as such. So the first thing we're going to look at is developer efficiency. For Spring Boot applications that we write, we use the Spring Boot starter, the initializer, and we're thinking of building our own version of that. That's Spring Boot initializer really allows that. It's built for that, so that you can are immediately compliant with a lot of these things just by generating the scaffolding for your application. And this then also pays off in the long run as you make more applications. The next one is fast. So we run on the cloud, primarily Azure, and Azure offers a lot. But how do we make changes? How do we allow the developers to use function as a service in a way that is compliant and is easy to use and integrate with other services? That's something where we're going to look at. And the final point is the auto recap. That's the next sheet. The auto update. So we have this. We have like 12 or so Spring Boot applications. They're all fairly similar. Of course, the logic changes, but the structure is similar. So when there is a new Spring version and we want to upgrade, then we unfortunately have this script to upgrade the POM to the latest parent. But it would be nice if there's an automated system which could do that for us. And I did hear that Brian talked about this yesterday. Unfortunately, I didn't view that stream. I will. And that allows us to easily migrate versions of components from a wide range of applications. So we're now looking into upgrading Spring Boot, because that's something that frequently happens. We're also looking into upgrading Java versions, because that now happens every 6 months. And that will allow the teams to keep up with their lifecycle management in an automated fashion, and which is also a requirement for compliance. Let's recap. So know the security requirements of your application using CRA. This makes it really easy to reason about what does my application need to do, and if there are changes in, for instance, the requirements, let's say your confidentiality changes, you want to bump up the strongness of your encryption, then you immediately know which applications to change. Put common logic in your runtime so that you don't have to duplicate that in every application that you have, and immediately have some of the measures required by the CIA in place. Use config as code, which allows you to be compliant, but write bots against it so that it's easier to do stuff. And use a singular pipeline, because otherwise you'll get burnt in the end. And it takes time, but it's well worth it in the long run. That's it. If you have questions, please let us know on Discord. Then Hans and I will have a definite look. Are there some interesting questions we can answer?
There are some interesting questions.
Cool.
Let me see. We have someone that asked the question, what's the best practice for storing secrets like passwords as config?
Yeah.
He already has some ideas self, but he's looking for new insights. Can you elaborate on that?
Yeah, so at Rabobank, as a platform, we use PCF. You might have heard of that. And for us, it's really easy to connect what we know as a service. And in that service, it allows you to configure secrets. And how that works is basically when your application starts up, there's a link between your application and the secret storage, and those secrets are automatically injected in your application. So they don't exist in your code, they don't exist in your configuration repository, but they exist in a separate, dedicated application designed for that, and they're injected by the platform into your application. And there are some other tools. I think the HashiCorp offers one. A Vault, that's the one I mean.
Key Vault, yeah.
Key Vault, yeah. So there are secret management applications out there which you can fairly easily bind to your applications, and then they will inject, or sometimes you have to retrieve the secrets, but that happens in a transparent fashion. I think that's a real benefit, because then there's a clear separation.
Yeah, thank you. You talked about the pipelines. Pipelines are also code.
Yeah.
How do you make sure that the 4 ICE principles that you put in your pipelines is not violated due to a change in the pipeline itself?
Oh, that's a good question. To be really fair, well, how we have set it up is we use Jenkins, and we've written these groovy scripts which you can run within Jenkins, and we have a test set, and that test set basically does a stack trace dump of a flow through the entire pipeline, and then it verifies that certain steps are present within that flow. So if you would remove it, then the test would fail because those pipeline steps are no longer triggered, and the test checks for those. That's how we have implemented it.
Okay. Another very nice question. Such a big organization as Rabobank, how can you mandate and manage that all teams use the same standard way of working and how can you get all teams, developers, up to the required knowledge level for secure software development?
Yeah, also a very good question. Yeah, the first one, I don't think you can get everyone on the same page. The organization is so big. There are many programming languages used, and those are usually associated with different kinds of people. I think Rosanne Joostens did a talk about that. So the same way of working, I don't think that works, because for instance, I wouldn't know, but how you write COBOL, I would view that probably different than Java. Getting it on the same page, I think cross-team communication is really important. So having discussions, how you do stuff, and we do that at Rabobank. We have many communities. We have, for instance, a community which handles how you define web APIs, and teams are invited to join those communities. For instance, I'm part of the Java community, and then we discuss how we approach stuff. So there, the knowledge sharing across the organization is done, but it definitely is challenging.
It is, I know.
Yeah. Unfortunately, it is. We're still people.
Yeah.
Yeah.
One of the other questions that came in is, you talked about one application you're working on, the
Edge router.
Edge router.
Yeah.
How do you avoid that people put in routes that create a security hole in the application? Because you talked about a bot who is checking the pull request.
Yeah.
But we all know that bots also have their programming errors.
Our bot is definitely not perfect. We still check it manually, but unfortunately we can't stop it all. Our application does some security checks, but in essence it's just routing traffic. We don't inspect the traffic contents, and we especially don't know what you do with that information. So if you make a security mistake, for instance, cross-site scripting, to name one, unfortunately we can't expect that. There are some other levels of layers of security scanning that maybe they intercept that, but that's out of my comfort zone. I don't know anything about that.
Okay. You talked about the pipeline library you are writing. Rabobank is also sometimes supporting open source.
Yeah.
Are you aware of that this is also something that will be brought into open source?
Yeah, we do open source stuff, but I don't think this is a real good candidate to be open sourced. We could, however, I don't think many people would benefit from that, because it's really specific, tied into the deployment. So the platform we use, which is PCF, the change management tool that we're using, the applications we use for code checking, and I think there's probably. I don't think it would be a real benefit to the open source community, but it's something we could definitely could consider, and maybe extract a part out of it. So I'll bring it to the stand-up on Monday.
I think that the ideas within that library can be beneficial for others.
Yeah.
Let me see. We didn't get any more questions.
If you have questions, now's the time to answer them. Otherwise, we can also call it quits. We'll still be available to answer some questions. Good point. Good point. Can I have those?
How can I get a great T-shirt?
Yes, because if you are active on our Discord, then you can. We have a couple of T-shirts to give out. I'm wearing one right now. It's I really like it.
I think we gave out the other ones, not the one you're wearing.
Fair enough. Yeah, I wouldn't use this one. I'm sitting in front of a lot of lamps, and I need a shower. But we'll definitely we'll hand those out for those who are active in the Discord channels. Cool. Yeah.
Thank you, Wouter, for your talk. I think we are up for a short break now, and then continue with the Q&A session with James Gosling later on.
Okay. Enjoy the main event, guys.